Greetings, peeps! We're going to switch modalities a little bit here and enter the virtual learning environment. This is my avatar, and notice that it's a little younger and hipper than the current Morad, but that's okay because in these imaginary virtual worlds, these are the things that we can do. So yay! I think I'm taking up too much of the screen. I'm going to make myself smaller to make room for all the great stuff we're going to talk about. So previously, we were looking at length, and we introduced the number line and a positive direction and negative direction, and also distance and displacement. So we're going to formalize those definitions before moving on with yet another example. Distance is the physical length of an object, or the length an object has moved. We measure that in meters because we're adhering to the MKS flavor of the System International. Distance is a scalar quantity, which means that it has just a simple numerical value, but you also need the unit, just like meters or miles or something like that. And it's always positive. So if you think of your car's odometer, it measures the number of miles that you go for the life of the car. So let's say your car reads 100,000 miles or 150,000 kilometers. In some cases it would, other countries. That's going to tell you how far the car has traveled throughout its lifetime. However, it should always be positive, but maybe some guys are trying to cheat you and roll that back a little bit so that it reads lower than it actually should, and that's not a good situation. So really it should always be positive and should always go forward. Displacement, however, is the length something is away from a point of origin. The displacement is a vector quantity, which means it has both magnitude, which is the numerical value, and direction. So an example of a displacement is an object that moves 5 meters to the east. East is a direction, and so it now becomes a vector. It's relative to some kind of origin, of course. Now, its value can be positive or negative. And a coordinate system, like the one we established in one dimension, a number line, uses to establish which direction is positive or negative. Now, coordinate systems can also be 2 or 3 dimensional. We're going to start with 1 dimension, but I'll show you a quick example of 2 dimensions as well. Welcome to the Enfield Square Mall, a place that I assume you are all rather familiar with. So we're going to use this as our place to showcase the example of distance and displacement in 1 dimension. What I want you to notice is that we've got a perfect linear corridor like the number line that would extend from Sears to Macy. Down here is a coordinate system that's based on the directions east, west, north, south. Notice that it's inverted. And it's inverted from our normal frame of reference because we're used to seeing north on top, south on the bottom, east over to the right, west over to the left. However, because Sears is to the left and that's the eastern direction, this is rotated, and that's perfectly fine, perfectly fine. We're only going to be using the east and west part down the corridor here, but in the future we'll be going into 2 dimensions as well. A mall rat's journey through the Enfield Square Mall begins at the center. Here's our origin, right here. Kind of right by Macy's Home and Men's, and Target is not too far away. Where I come from, it's called Target. I understand in this town it's Target. Either way, that's quite fine. So notice that if this is our origin, in the positive direction, we'll head towards Macy's, which is 125 meters away. So this is 125 meters in the positive direction. If we go in the negative direction, 125 meters, we're at Sears. So that would actually be east physically and Macy's to the west physically, relative to the starting point over here, our origin. Given a table of displacements relative to the mall rat's previous position, what we want to do is determine a couple things. We want to determine the displacement from the origin and the distance traveled for this mall rat. And as a little extra credit, bonus, I am going to allow you to try to figure out, hey, what stores or restaurants are at each location relative to the origin. Okay, so what we have here is our table. It's the displacement from the previous position. We're going to start at the origin. So that means we'll go in a positive direction for 75 meters, and then from that location go in the negative direction 25 meters. Positive 35, negative 110, and negative 30. To analyze this, I've got a little matrix set up in Excel. Here we go. Now, we have the information listed here, and we have all of our displacements relative to the previous position. And what we're going to try to figure out first is row by row the displacement from the origin and the distance, and then figure out our total distance for the entire journey and our final displacement. Where are we at after all this? Or actually, where is the mall at? Okay, if we move 75 meters, the displacement from the origin should be 75 meters, okay? So in the first case, we're starting at the origin, so this should be completely matched. And so that is absolutely the case, that we're going to move 75 meters in the positive direction. What's the distance we traveled? Well, it's also going to be 75 meters, okay? Next, we're at position 75. We're going to move negative 25. And so our displacement from the origin will be 75 minus 25, or 50. What is the distance traveled? Well, it's going to be 100 meters, because we've traveled 75 meters in the positive direction and 25 meters in the negative direction. In total, 75 and 25 is 100. Okay, and notice that this is always positive. It's always going to increase. Okay, next. Well, we're at position 50, and we're going to go in the positive direction 35. So that means we're going to be at 85 meters in the positive direction relative to the origin. That's the position that we'll be at. Now the distance that we'll be traveling in total from the beginning is 100 plus this 35, which should be 135 meters. Now we're traveling a whole 110 meters in the negative direction, okay? Which means we'll actually go past the origin into the negative territory. So let's see where we end up. Negative 25 meters, okay? What's the distance? It's 135 plus this 110 for the total journey so far, which is 245 meters. Okay, now we go another 30 meters in the negative direction towards Sears. Okay, so we're starting at this position here, negative 25. We're going to end up at negative 55. How far did we travel in total? 245 plus 30, and we have 275 meters traveled so far. So the total distance traveled is going to be 275 meters. That's just the rolling total here. That's where we ended up. Final displacement, you can actually now look up. We end up at position negative 55, so closer towards Sears than Macy's. I brought you back to the map of the Enfield Square Mall, and this time I've posted our data from before, where we now can see our displacement from the origin. What I'd like to do is actually map out those positions so we can see them on the map and our locations relative to the origin and also to Sears and Macy's. Okay, so what I'm going to do is realize we start at the origin and we move to position positive 75. So here's 125. In between is about 62.5, interestingly. So we're probably around over here. Then we move to position 50, which may be approximately over here. Then up to position 85, which might be up here. And then we go all the way to position negative 25, which is perhaps around here. This is just a quick estimate. And negative 55. Of course, if we wanted to measure this out in a more accurate way, we would do so with some kind of scale and measurement. But these are approximate locations. So it gives you some clues about what might be there upon looking them up. Or maybe you just know because you hang out there a lot. We're back at the Enfield Square Mall, this time with a new look. We're going to track the mall rat's displacement and distance traveled. This time we're given a table of the displacements from the origin. And we're going to look for the mall rat's displacement relative to his/her previous position. Maybe it's a dog too, the dog. Okay. We don't, it could be an actual rat. Could be a rat. Never thought of that. Yes. And as extra credit, we'll try to figure out the places here as well. Okay. The great thing is that we can actually start a map immediately because we have displacements from the origin. So we know our positions relative to here. So we're going to estimate those right now. So for example, I'll grab a pen and make sure that it's ink that is useful to us. Black ink is good. That shows up nicely here. And we start off at the origin and notice that in the mall rat's first leg of the journey, they're going to go negative 45. So to position negative 45 like that. So probably somewhere around there, not quite halfway. Then the mall rat will go to position 85, which goes through the origin, and then over here, past the halfway mark, maybe it's somewhere around here as an estimate, okay? Then the mall rat goes to position 125, which is clearly easy because it's this line over here. 125 meters is actually at the door of Macy's. Then the mall rat goes backwards towards the origin to position 95. So it's maybe somewhere around here, like so. Let's take a look at that in some detail and actually make some of the calculations to find displacement relative to his or her previous position and the distance traveled. Here we are. Okay, here's our table, and let's do these calculations out. Okay, we will notice that we start off at the origin, or the mall rat starts off at the origin, goes towards Sears at a distance of 45 meters in the negative direction. So the displacement relative to the previous position, which was 0, will be the same thing, negative 45. And the distance, positive 45. That's how far the mall rat has gone in that leg. Okay, now, as we mentioned before, we start off at position negative 45, then go to position 85. We're going to go through the origin back to the other side to position 85. Okay, so what's the displacement? Well, it's a positive displacement because you're going from left to right. That's towards Macy's. That's the, well, in this case, that would be the westerly direction. All right, so we're going to go 45 meters to the origin and then another 85 meters. So we've traveled, the displacement would actually be 130 in the positive direction. How far have we traveled? 45 plus 130, 175. Okay, next we go from position 85 to position 125. Okay, so that's 40 meters in the positive direction. So that means the displacement is positive 40. Okay, and then we add that to the 175 to get our 215 for distance in meters so far. Okay, then we go, the mall rat goes backwards from 125 Macy's to wherever position 95 is. And that means it'll be a negative displacement because we're going from a higher value to a lower value in this case. And that's going to be an amount of negative 30, but the distance always is positive, always accrues, which means we're going to be at 245. So the total distance is 245 meters. And the final displacement is going to be actually 95, something we could have read at the very beginning. We could have done this first even. It's low-hanging fruit. That's what it is, okay? Position 95 relative to the origin. Okay, that's what it is. We are done with this lesson. And what I'm going to say is Morad out.